load curve. Now the load on the power station is not constant, but it is continuously changes. Now the graph between the time versus load is called load curve. That means when we draw the graph between time versus load is called load curve. So that means load curves represents the graphical relationship between times and the load. So it is most important. Now if we draw a graph in descending order of how much load has been on power station for how long time, so we get the load duration curve. That means load duration curve, that means from this graph we can decide how much loads present on the power station for one period. First, load curve. Then now the load on the power stations is different types, and each and every loads which are connected in the power station has different characteristics, and they are on or off according to its requirement. Now due to these loads on the power station is not remain constant, but it is continuously changes. Now the graph between the graphical relationship between chronological time and the load on the power station is called load curve. What is the load curve? Load curve, it is nothing but it is a graphical relationship between chronological time and the loads presence on the power station is called load curve. Now the load, it is taken into kilowatt or megawatt, and the time is taken into hours. So that time this curve is known as a daily load curve. So do you understand? When the graph is drawn between time and load, chronological time and load on the power station is called load curve. When the load taken into kilowatts and time taken into hours, so this type of load curve is known as a daily load curve. But if we are taking time in hours, numbers of hours present in the week, so that time this type curve is known as a weekly load curve. Now similarly, if we are taking time in terms of month, we are considering the numbers of hours available in the month, that time this curve is known as a monthly curve. Now similarly, we can take time in yearly, that means numbers of hours in the year. Numbers of hours in the year we are taking, so that time curve is called yearly load curve. Now out of them, the daily load curve and yearly load curve is most important and it is widely used. Now the different day, the load curves looks as a similar characteristics, but in exact condition they are not same, because the loads curves during the summer period is different than the load curve in the winter days or winter session. Here we can say one most important thing is in mind that the value of the load is not taken its instantaneous value. That means instantaneous value, that means the value of load at particular time, particular instant. So here we are not taking the load at the instantaneous value, but we are taking a change of 15 minutes or half an hour is taken as an average load. We are taking, what happened? We are taking 15 minutes or 1/2 hour is taken as an average, and this average is taken as a demand for that particular time. Now next, what are the information available from the load curve. So following informations we are able to know from the load curve. So first, each provide the information about the loads available on the power station at any time. So if you want to require the value of load at particular time, so you will get this data from this load curve. Second, the peak load of curves indicates the maximum loads on the power stations. Third, the area under the curve indicates the numbers of units generated in the power station. You can also find out average demand. That means it is a ratio between area under the curve to the base. So already we have seen area under the curve, it is nothing but numbers of units generated during day divided by 24. So if we find out the average load demand during the hour, during the year, so from this equation we can find out numbers of units generated during the year divided by 8760. That is 8760, it is nothing but numbers of hours of the year. Fifth, you can also find out the load factor. So what is load factor? So it is the ratio between the area under the curve and the area in rectangular curve. You can also define as it is the numbers of units generated divided by maximum demands into hour. So if the load curve is, if the daily load curve, then we can find out daily load factor is equal to numbers of units generated during the day divided by maximum demand into 24. If yearly load curve is present, so we can find out load factor, yearly load factor is equal to numbers of units generated during the year, whole year, divided by maximum demand into 8760. Now the ratio between generated unit and time. The load factor is equal to, we can find out average demand divided by maximum demand. Because generated unit divided by this time, we can write average demand. So you can also find, we can write load factor is equal to average demand divided by maximum demand. Now generally the load factor is represented in terms of percentage.